I'd like to welcome the panel presenters and our moderator for this session, Markos Scheer with Seagrove Kelp Co. to the stage. Thank you.
Great, thank you, Hannah, and thank you, Tomi. So excited you guys are here today. Welcome everybody again back. This has been really interesting, and we're just getting started. So first, I'd like to welcome the panel to the stage here. We have Angela Korabik. I got that right. See, first time. I can be taught. Here with NOAA, we have Lexa Meyer, Cliff Goudey, and Mike Stekoll. And at the conclusion of our presentations, we'll have an opportunity for questions on Slido and with the microphone. I'll be up here, so you won't have to hear any questions from me. I'm sure you'll appreciate that. And just want to say, think of questions throughout this. Put them into the get ready for the Slido opportunities to have some great discussions. Our first presenter, Angela, with NOAA AFSC, is presenting an abstract titled The Successes and Challenges of Growing Bull Kelp in Alaska. And as someone who tried to grow a lot of bull kelp for several years, I'm really looking forward to hearing what she has to say. Angela? You can see here, we've got so this will advance a slide. Okay, got it?
Hi, everyone. Thanks so much for coming today. I'm excited to talk to you all about the successes and challenges of growing bull kelp in Alaska. I'm currently an Alaska Sea Grant State Fellow, housed at NOAA AFSC in Kodiak. So bull kelp, Nereocystis leuciana, is a really cool species because it's particularly unique to the U.S. West Coast. It's only really found from California up to Alaska, and so from like a growing perspective, Alaska is really poised to have like a unique market. It provides a number of important ecological services, such as providing habitat for commercially important fish species, and then it's also extremely valuable for human consumption. The question is, though, how do we transition away from wild kelp harvest? Majority of the bull kelp on the market right now is currently sourced from wild harvest, but that's not always sustainable. Currently, supplies tends to be limited by how much producers are permitted to collect, and so there's a little bit of a limit to how far the market can grow at the moment. Bull kelp farming can help increase market supply while also reducing reliance on valuable wild forests. The problem is, bull kelp's pretty hard to grow. It has a really unique morphology in that it has a hollow stipe that makes it highly buoyant. As a result, on farms, it tends to stay small and skinny and tangle a lot, and it becomes really hard for producers or for harvesters to actually process it at harvest. Barnacle Seafoods has recently produced a document of lessons learned in bull kelp farming, which provides a lot of really interesting information. But the question still remains: how do we grow wild-type bull kelp in farmed setting? Recently, Leah Heifetz of Barnacle Seafoods and Sherry Manzer of UAF came to my supervisor, Alex Ferrier, asking for help kind of forming a collaboration of bull kelp farmers and researchers in Alaska. There's a lot of research being done, but a lot of people weren't talking to each other previously, so there's kind of a desire to kind of bring everybody together to kind of collaboratively figure out the answers to some of the questions we have. As a result, in October 2023, the Bull Kelp Research Squad was formed, and I, in addition to Alex, my supervisor, am a co-coordinator of this group. The goal of this group is to develop a current understanding of how we're growing bull kelp in Alaska and what is and is not working, with the end goal of developing a proof of concept for how to grow bull kelp and make that operation scalable. Currently in scope for our group is really just focusing on the challenge of growing bull kelp. So mostly from like a research and biological standpoint, we don't really have a lot of economic and permitting policy expertise, so that's currently out of scope for our group. Currently, Beakers is comprised of 20 members, including Mike and Lexa up here, so shout out, and Tamsin earlier, who you heard talk. So we have 9 kelp farmers, 6 researchers and 4 agency members representing 11 different organizations. So a variety of kelp farms such as Kodiak Island Sustainable Seaweed, Alaska Ocean Farms, Sequester Farms, Kelp and Koru Hatchery, Native Conservancy, and the Native Village of Ayak. We also have several industry members such as Green Wave and Barnacle Seafoods, 2 campuses for the University of Alaska, so UA-SC and UA Fairbanks, as well as 2 agencies, so Sea Grant Alaska and the Alaska Fisheries Science Center. And then we were also recently joined by a member from the Prince William Sound Science Center. So far, in the short time that we've been a group since October, we've actually gotten to do a lot. So what we've done so far is I've conducted one-on-one interviews with group members to understand their experiences and perspectives surrounding bull kelp farming. We've also begun to openly share farm and experimental designs and goals to see how exactly we're testing some of these different challenges. With that, we've also developed a list of successes and challenges for what is and is not working in the bull kelp farming, as well as a list of questions and areas for future research. And most recently, we also developed the first draft of an SOP for bull kelp farm and research monitoring, so that even though we all have like different farm and experimental designs, we're at least collecting data the same way, so we can compare it at the end of the harvest season. So today I'll be mostly focusing on the results of these one-on-one interviews and the actual list of successes and challenges that I collected from these. And also I want to highlight that within Beakers, there are 10 different projects ongoing. So a few were completed last year, but there's quite a few projects ongoing this year that are hopefully we'll see some really exciting results at harvest. So based on the comments from the one-on-one interviews, I've identified 14 main categories for successes and challenges in bull kelp farming. So we have seeding and density, array design, experimental design standardization, depth, weight and buoyancy, sporophyte growth, abiotic and environmental parameters, genetics, nutritional quality, ecological community impacts, contamination, processing, markets, and permitting and policy. Of these, only a few categories actually have shown successes. So that's seeding and density, array design, depth, weight and buoyancy, abiotic/environmental parameters, ecological community impacts, and markets. And the one I'm gonna really kind of shout out and highlight today is our successes in seeding and density. So the highlighted success for seeding is that reproductive material is actually really easy to collect for bull kelp. Bull kelp, as many of you might know, it is a very tall species, so like a lot of the reproductive material is available at the surface. So you don't actually have to dive or do any like scuba or anything to actually collect this reproductive material. You can just lean over the side of the boat and pull it on to your boat. And there's actually a picture of me with a really nicely reproductive sori that I collected last week, or a few weeks ago. Additionally, once you have the reproductive material, spores release really easily and quickly, and they successfully recruit and settle at extremely low densities. And so this is a really cool picture of some seed pipes grown by Tamsin Peoples, showing how easily these pipes can become covered with bull kelp spores. Additionally, there have been reports that bull kelp microstages grow faster relative to other kelp species. However, while we are seeing some successes in areas like seeding, a lot of the successes we're seeing are still paired with a challenge. So while we are seeing that seeding bull kelp is really easy and you can get really good coverage as low as 100 spores per milliliter, too high densities make growth and processing challenging. Additionally, bull kelp grows really well on most arrays it's planted on, but no farms have been successful at growing the desired morphology of bull kelp. Next, bull kelp grows really well in deeper settings, but maintaining specific depths is really difficult with how buoyant bull kelp becomes and how it pulls on traditional kelp arrays. Additionally, adding weight to catenary lines helps to keep bull kelp deeper and growing better, but the amount of weight needed to actually counteract the bull kelp buoyancy provides transportation and ergonomic challenges. So looking a little bit closer at our challenges now, we can kind of see that there's challenges in basically every category except nutrients. And the only reason nutritional quality is not included in the list of challenges is because we still just don't really know a lot about the nutritional quality of bull kelp. It hasn't really been studied, so it's been kind of hard to quantify like where there are challenges to nutritional quality or not. So today I'm going to focus on 3 main challenges. So we're going to focus on density, buoyancy, and depth. And I'm going to kind of talk a little bit about what the Beakers members are doing to study how to counteract those challenges. So the first highlighted challenge is density. As I mentioned, bull kelp spores settle well, but they almost settle a little too well, where even at super low densities, you find a line that's completely covered in bull kelp spores. This creates an extremely high density of plants on lines, and the interspecific competition from the plants means that while you have more plants, each plant grows less. So you're not really getting that wild type, like really thick, beautiful stipe that you would see from wild harvest. Additionally, these small, skinny plants can lead to challenges harvesting bull kelp. It's difficult to untangle, sort, and clean, and so it's maybe not always the most useful, but it could be. So one experiment that is being done by beakers right now is low-density experiments on Alaska ocean farms, and so this is being run by Lexa Meyer and Alf Pryor. And so what Alaska Ocean Farms is doing is they're, in addition to looking at extremely low densities of kelp, so settling seed lines at densities of 100 spores per milliliter, they're also spacing out where they put the seed line on the rope. So they're kind of using this method where they, blanking on words, but like stick a little piece of seed string into the grow line, and they're spacing it out either every 1 meter or every 1.5 meters to see how not only these low densities of seed, but also spacing out these seed can impact the kelp growth. And then they're doing that on their farm. And we're really excited to see what the results of this are. The next challenge I want to highlight is buoyancy. So as I mentioned before, bull kelp is highly buoyant. It has this hollow stipe that you can kind of see in this beautiful image by Josie Islin. And as it grows, it starts to pull lines to the surface. And so the challenge that kind of comes from this is how do we keep bull kelp below the water surface? And there's a few potential solutions for this. So one is adding weights over the season, another is sinking the lines, another is developing benthic arrays. But each of these potential solutions have their own challenges. Adding weights over the season is very costly in terms of money, time, and then it's also just ergonomically challenging. Placing weights like every few meters is a lot of bending down while holding a lot of weight in your hand. Sinking the lines can just be really challenging in terms of engineering, and then developing benthic arrays sometimes can be challenging in that to check on your farm you might need divers or some way to like lift the whole benthic array up to the surface so you can check on it in the middle of the season. But the basis beyond like all of these challenges with buoyancy is we still don't understand some of the fundamentals about how does bull kelp buoyancy change over time. So one project that's being looked at is the buoyancy measurements by the native village of Ayak. And so Caitlin McKinstry, the biologist for the native village of Ayak, is running this program. And so what she's doing is she has seeded some crab pots that are set 20 feet below the water surface and is checking on them periodically over the course of their growth season to see how much force is needed to actually submerge the bull kelp every few months within this growth. Right now the pots have just been seeded, so you can kind of see there's like one tiny little kelp baby in that picture. So they're really small, so it kind of can't really look at any buoyancy yet, but hopefully in the next few months we'll see some really cool data come out of this project. And then the last challenge I want to highlight today is depth. And so depth is really tied to buoyancy and density as well. So the standard depth for most kelp catenaries is about 6 feet below the water surface, which for species such as sugar kelp or ribbon kelp, which are neutrally buoyant, it's great. If you set a seed line 6 feet below, they're gonna stay 6 feet below. But as I mentioned, bull kelp is very positively buoyant, so as it grows, it's gonna pull that up towards the water surface. And the sooner it gets to the water surface, the sooner it might be exposed to negative effects of exposure, such as bleaching, sunburn, or freezing. Additionally, some previous results from previous studies where lines accidentally sank did find that they saw better bull kelp, so thicker, more robust when it was at deeper levels. So one project looking at depth are the depth arrays being run by Sequester, so Johnny Antony, Liv Dooner, and Tamsin Peoples. And so what they're doing is they have a few different cool arrays that they're setting out. So they're anchoring some of their lines to the bottom, like on a single line, where they have a monkey fist at the end of the line, and that monkey fist is then seeded. And so they're kind of looking at different distinct depths with that to see how these depths affect bull kelp growth over time. Additionally, they have a really cool paired valley and peak arrays where they can look at a gradient of depth and how that affects bull kelp growth, both by looking at depth of kelp relative to the surface as well as depth of kelp relative to the bottom. So kind of including some of that tidal exposure that might come, that might not be experienced from a catenary array that floats. And so these are a lot of projects. The Beakers group has a lot going on, and clearly we have a lot of challenges ahead of us. And so the future of bull kelp farming is going to be interesting. We have many challenges that need to be addressed still, but the work being done by Beakers is really exciting and innovating, and hopefully making some really cool strides in addressing these challenges. Additionally, we are now starting to prioritize areas for future research, and hopefully we'll start to be collaborating on some funding proposals for future RFPs. Additionally, we hope to start, at some point, start to concurrently consider processing and market constraints in addition to looking at the biological restrictions of growing bull kelp in Alaska. And hopefully after this harvest season, we'll see some really cool progress in the bull kelp that's being produced in Alaska. With that, thank you so much to all the Beakers members, my supervisor, Alex, and also if you are interested in joining Beakers or at least getting more info, feel free to scan this QR code. It'll take you to a little survey. I also have this QR code printed out on the NOAA table. So thank you.
Great, thank you very much. That was really interesting. I'm really excited to see how the results of those various arrays and what that might do. I know we spent many hours trying to sink bull kelp and agree that it is not a viable option. So appreciate that. Thank you very much. And our next presenter is Cliff Goudey with CA Goudey and Associates, is presenting an abstract titled "Advancements in Commercial Scale Farm Design for Seaweeds and Shellfish." Cliff? Well.
Thank you. Thank you, Markos. I'm going to be talking largely about a number of projects that have been involved in, and some that is kind of on the drawing board. This first slide is mainly focused on the Kodiak project, the one that was sponsored by ARPA-E, and that's something that's been going on for 4 years or so. And to me, it's a hugely successful project because of the things that we've learned, the mistakes we've made, the way we've been able to fix and recover from those problems. And we were able to get a quick start because we were able to use Nick Mangini's permitted site just inside of Popoff Island. It's an area that's pretty well protected from any swell that comes in from the Gulf of Alaska, but nevertheless, it still can be a quite exposed site. It's close to port, which makes it handy. There's very good bottom for drag embedment anchors, and the area seems to be quite productive, maybe because of the proximity of all the fishing industry activity going on in the port of Kodiak. So the array that we came up with is something that's is sort of a version of what we first tried in Massachusetts, but it's using the principle of catenary line. Now, there's nothing particularly new about that, but what we're talking about is stringing lines between two opposite lines, sometimes called header lines or framing lines. If you do that, you end up with a catenary, regardless of how you do it. The difference in what we're trying to do is we pre-calculate that. The goal being to end up with uniform tension across every one of those grow lines, and in doing so, the hope is that you can make those lines closer and you can increase the productivity in a given water sheet area, and I think we've done pretty well, as particularly compared to the idea of using individual lines, or kind of throwing caution to the wind and having lines close enough together that you certainly can't get boats between them. So this arrangement that we have here has two modules, each having 55 lines. So the total length of the size that we ended up with, we sort of increased each year. I had 44,000 feet of grow line, and with pretty good and quite competitive growth on each of those lines. The spacing between those lines was about 2.5 feet. And in all of these cases, whether it's sugar kelp or bull kelp, you're fighting with gravity, either in the form of too much buoyancy or too much weight. In the case of sugar kelp, it's weight, and you're constantly trying to keep it from sinking. The key to solving that is providing pretension. Otherwise, you have a lot of sag in the lines, and they get down beyond what the optimum depth is. So a lot of flotation, set lines across in the middle to help support it. And it worked pretty well, and I think there's still a lot of issues that need to be perfected on this kind of a system. And I think that's going to, those are going to be solved just by having this kind of a system out in practice, and people will figure out better ways of doing it than we had time to do. A second project that I want to talk about, I had less involvement in this, and you're going to hear a bit more about it from the next two speakers, and that is taking this catenary approach and using it for something that's very different. Instead of a crop that's heavy, a crop that's buoyant. And time will tell what works out to be the commercial solution for that, but I'm going to throw this out as an idea, which is an adaptation of the same idea of a catenary rig, but instead of being supported at the surface by floats, it's held to the bottom by anchors and weights. And so what you see here is there's still 4 corner buoys, but they're not the intrusive buoys that Den was talking about. Dune was talking about, I'm sorry. They're submerged, and the only thing that's at the surface in this farm is some small pickup buoys, which aren't used to hoist it. They're instead used to put air down into these hollow aluminum floats and bring the whole system to the surface for harvest or whatever other monitoring you want to do. So I think the jury is out on what the best way to do this is. But I think, personally, I think pinning it to the bottom and have it as close to what nature, how bull kelp evolved, being added to the surface, you end up with maybe the optimal product. I don't know. It depends on what the market wants. Last thing I want to talk about is we've applied this kind of a setup to oyster farming up in Maine. This is a large operation, Mook Sea Farm on the Damariscotta River, probably the best oyster farming area in Maine. And it's a big operation. Mook Sea Farms produces seed for most of the East Coast. They're the biggest producer, and I think they're probably the biggest producer of adults as well. But they've got big arrays on floating arrays, mostly individually anchored. But they're having problems with those systems breaking down, and so we've converted their farm system to using catenary, and here we have a 4-module array, and it's still in the process of being installed. But the advantage that this system will have is it applies the right kind of pretension, which means the mechanized processes that they have for cage flipping and harvesting and sinking in the fall and raising the farm in the summer, because this place freezes over, is going to work quite well. So the jury is out on how well this works. This is the first time this system has been applied to shellfish, so I'm hopeful that it works. That's all I have.
Yeah, thank you, Cliff. Very interesting. We we have a oyster growth system on very similar to that outside of Craig. I'd be love to talk to you about it, since we have a similar project in way. So our next presenter is Lexa Meyer with the University of Alaska Fairbanks, and she is presenting an abstract entitled Effects of Farm Line Spacing on Cultivated Alaria Marginata, a methodology for determining optimal line spacing. Lexa.
All right, thank you. Thank you for the introduction. Wasting no time with our 5-minute limit here. Yes, this is my graduate thesis. Dr. Sherry Manzer is my advisor, and this has been 2 years in the making. So 5 minutes summed up into, the 2 years of my life summed up into 5 minutes. So here we go. All right, clock's ticking. Okay, so why is line spacing important? Why do we care? One of the big reasons is economical. Kelp farms, the leases are expensive. Some of you out here know that all too well. If you want to farm on a larger scale, you're going to lease a bigger plot from the state, and that is thousands of dollars out of your pocket a year. So you want to optimize that area and grow as much kelp as you can in there. And as fortunately markets hopefully develop and all these things, it's just going to become more and more important over time. And then, also alaria marginata. It seems like, why ribbon kelp? A lot of people farm sugar kelp. We've had a lot of buzz around bull kelp. Well, alaria is actually the second most commonly farmed species in Alaska right now. And so there are very little studies pertaining to its growth, habits, and all of these things. So I figured, heck, let's run with alaria. Plus, it's beautiful. I like it. So to test this, we're like, well, how do we test line spacing? So the catenary system, as was demonstrated by Cliff, doesn't lend itself well to altering the line spacing. Basically, you have to have all the lines the same distance apart. So to do this, we used a spreader bar array system, and that uses bars to maintain the fixed distance, and we were able to alter the line density. So we have all the way from 6 foot, which is kind of like a common line spacing, 4 foot spacing, 3 foot spacing, 2 foot spacing, and all the way down to 1 foot spacing on the same array. And so what we did is we made sure we had replicates. So we had 3 of these arrays outplanted at the same location within about 20 or so feet, 30 or 40 feet apart on our lease in Cowlison Bay over 2 seasons. And the ultimate goal of the project was to assess the effective line spacing on the yield per foot, the total yield, and as well as the phenotype or the appearance of the kelp. So blade thickness, blade width, blade length, all of those things, and see how the line spacing impacted those parameters. And so this is what we saw. And these results were remarkably consistent between the 2 years, which was fantastic. And this picture is kind of what sums up the project, I think. And you can see from left to right, we have 6 foot, 4 foot, 3 foot, 2 foot, and 1 foot spacing. And you can see what happened to the kelp. We had a reduction in, these are small subsamples taken from the farm. They're half-meter subsamples. And so you can see that we had a reduction in yield per foot as we decreased our line spacing. Larger line spacing, we had more kelp per linear area on the farm structures. And the kelp overall, the size of the kelp was impacted, so the blade length. And so, results. So I kept the 2 years separate just because I like to illustrate that there was an impact that was seen over the 2 years and that those results were consistent between the 2 years, which I find fascinating. So on the bottom axis, we have the line spacing, 1 through 6, and then on the vertical axis, we have the average harvested biomass, and this is the total biomass harvested in those little treatments on the farm. So we had 3 of those arrays, so we had 3 treatments, we took the average of the total yield. And 2022 is blue, 2023 is green, if you're there in the back and can't read it. And what we saw was what we thought we thought we would see, is that if you simply have more lines in the water, you get more kelp. So in the 6 foot spacing, the total treatment was only 3 lines, which is kind of remarkable. That's all you get in their 6 foot spacing in that block on that array. If you go all the way down to 1 foot spacing, you actually had 13 lines in the water. So you were growing, overall, you just had more capacity to grow kelp. However, when you look at the yield per linear area, so the yield per foot, that was the inverse. You actually had a higher yield per foot in the 6 foot treatment versus especially like the 1 foot treatment. So your yield per area went down. And what was interesting is this is mirrored by your average blade length. So I think this is pretty cool. You get bigger blades when you have more line spacing, and you get smaller blades when you have less line spacing. Other parameters measured, like the other phenotypic parameters and so forth, didn't show a significant correlation with the line spacing treatments. So that, in a nutshell, is my project. Those are the main findings. I'll have a poster this evening, so come bug me if you want more information. And then if you are after the conference, you need more info, please reach out to me. I'd like to talk more about this. The full thesis should be due out sometime later this year, early next year. So thank you so much.
Yeah, thank you, Lexa. That was really interesting. Although I got to say, it wasn't entirely clear to me what the optimal was because there's such a trade-off between them. Anyway, we'll figure. I guess we'll get into that in the Q&A. Oh, very good. All right. Let's see if I can figure out how to make this advance. Hey, look at that. I can be taught. So thank you, Lexa. Our next presenter, Dr. Michael Stekoll with the University of Alaska Fairbanks, is presenting an abstract titled Increasing Farm Yield, Co-Culturing of 2 Kelp Species. Mike?
goes forward. Okay. Thank you. I'm going to talk today about our little project that we're doing up in Kodiak last year. It was an outshoot of another project we're doing with ARPA-E, funded by the Department of Energy, ARPA-E system, where we were growing large amounts of saccharina for potential biofuel using the catenary array that Cliff was talking about. And while we were doing this, the idea came up as, well, the saccharina grows down. Why don't we just put another kelp with it that grows up, like bull kelp, for example? So that was an idea to start this. And this picture is just a picture of the farm in late May, actually, just to show you that we actually did something. And those little rectangles there are each of our treatments, which I'll show you here in a minute. So this is our farm design, and the idea was here, like I said, grow sugar kelp and bull kelp together, and then also compare that to bull kelp alone and sugar kelp alone. So we had 3 different treatments then, where we had both sugar and bull kelp on the left there, and a bull kelp in the middle, which is the black lines, and sugar kelp are the red lines. And we replicated this 4 times in this farm. And the farm we're using was Alf Pryor's farm off of Goudey Island. And thank you, Alf, for setting this all up, and for Lexa for providing the seed. So each of those modules there, 30 feet long, about 10 feet wide, which gave us a spacing of 15 inches between the lines. Okay, fairly close together. And the point of this was not to see how much we could get per line, but how much we could get per meter squared, per unit area. You try to increase the yield per unit area. And this is Lexa putting out 9 lines of bull kelp on one of the arrays. They were outplanted around February, 1st of February, and we harvested around the last of June, 1st of July. Okay. So our results. This is kilograms per meter results. And so on the left is the combined array with the red things being Nereocystis or bull kelp, and the sort of the turquoise color being saccharina. And one of the interesting things here is that per meter, we had much higher yield per meter on the combined array, where we had 5 lines of Nereocystis compared to all Nereocystis, all bull kelp array, so about twice as much yield per meter, 14 kilograms per meter compared to 7.7 kilograms per meter. So that looks like there may be a function here of spacing, but when we look at the saccharina, they had the same yield per meter, all right, both around 6 kilograms per meter. So our conclusion here, is that line spacing plays a large overall yield for bull kelp, but doesn't seem to be that important for sugar kelp. And this is, of course, given the constraints we had for our experiment. And then finally, we have the real results here that I want to talk about is the kilograms per square meter that we have. And on the left again is the Nereocystis, or the bull kelp from the combined array, compared to the Nereocystis by itself. And we look at this, we see that the total yield per meter, basically, or the total yield on one of those arrays, is about the same for these, even though the bull kelp in the combined array only had 5 lines compared to 9 lines on the bull kelp only array. So total yield for bull kelp was, over the entire farm, was slightly more, a little bit, almost the same, but slightly more, having 45% fewer lines. And so that was there. The yield per meter squared then, so we have to add the red and the turquoise on the left side together to get the total yield. And notice that it doesn't start at 0 down there, it starts at around 200. So the total yield for bull kelp alone on the 9 lines was 5.74 kilograms per meter squared. For the sugar kelp, 4.31 kilograms per meter squared. And for the combination, adding the two together, 7.53 kilograms per meter squared. So we had more yield per area combining the two species together than we did either one of them alone. So overall, we had about 31% more biomass per array compared to bull kelp alone, and 75% more biomass per unit area compared to sugar kelp alone. So thank you.
Well, thank you, Mike. That was really interesting. A lot of food for thought. Thank you all for really terrific presentations and for the work that you're doing. Really meaningful work in a lot of different areas to move the industry along. So our next section is an opportunity for folks in the audience to ask questions, either through the Slido QR, if you can log on to that, or if you just want to raise your hand, and there are people with microphones that will come to you to ask questions. And I'll read the questions as they come up on the screen here. We don't have any yet, so we have a question over here. And we have a question over here. Oh,
Hi.
James?
My name is Thomas James. I'm the farm manager for Seagrove Kelp. I had a question for you, sir. So with your analysis of the kelps growing better together, do you think that's due to them having different nutrient requirements, perhaps that they don't have to compete as much side by side, whereas when you grow them individually, you notice less growth?
The combination had the bull kelp pulled the lines up towards near the surface, and the sugar kelp, because it actually is negatively buoyant, pulled it down. So the actual spacing between each species was 30 inches instead of the 15 inches. So that possibly is due to either shading or nutrients. Either one could be enhanced by that fact.
Okay. Yeah. Thank you very much.
Yeah, thank you. Thank you, Thomas. We have a question over here as well.
Hi, thanks everyone. This is a good follow-up to his question. Mike, did you find that the weight matched the buoyancy? Like, do they grow well together in that sense?
No.
Which one out?
Buoyancy,
more buoyant, more weight.
Buoyancy is much more than the weight.
Uh-huh.
And those are baby plants that we we didn't grow the big ones.
Great. Any other questions from the audience? We have a couple on the screen here. And I think this must be, this one's for Lexa. What density of alaria was the most profitable? I'm not sure how to describe profitable.
Right.
And kelp in the same
So
sense.
that's a question I know I'm going to get a lot of this evening from our farmers. It's an excellent question. I have not performed a full techno-economic analysis of the different line spacings as of yet. I would guess that it lies somewhere between the 3 and 4 foot spacing. Just by looking at things, you get more yield per unit area plus more yield overall out of those two treatments. But again, this isn't a full analysis. What I would say is that it can also depend on your market. So if you're growing for just biomass, like to produce a lot of kelp, then you're going to look at your highest yield overall and your highest yield per meter. But if you're going to grow for a specific phenotype, so if you have to grow like long blades or, thick blades or something else, especially length, which was correlated to density. So if you want longer, bigger blades for your market, then you might consider a larger line spacing, maybe even going up to 6 feet and beyond. So it's going to be dictated by many factors. But yeah, it'll be hot off the presses sometime. Like I said, later this year, I'll have more information on that.
Oh, great, thank you. Cliff, is there a question for you? Is there any added risk of marine mammal entanglement, specifically whales, when using catenary lines, specifically when anchored to the bottom?
It's a great question. I don't think so, and based on our experience, it seems that the hazards of marine mammal entanglement is related primarily to loose lines in the water, not tight lines in the water, and that's why the importance of having pretension and having uniform tension across the farm is so important. If you bounce up against a line that's tight, pretty difficult to get tangled in it. I'm sure it's possible, but it's so far we haven't had problems. This is a huge issue on the East Coast related to passive fishing and lobster gear in general, but it seems to be the vertical lines attached to a floating buoy, which is by their nature are loose lines, which kind of, I'm not sure they encourage, but they certainly allow it. So no, I don't think it's a problem. I don't see sending it to the bottom or having it pinned to the bottom makes it any worse or any better.
Yeah, thank you. Let's see, lots of questions here. Has anyone used force transducers on bull kelp lines to measure changes in tension over the season? It's a question for you, I think, Angie.
That's a good question. So as far as I'm aware, there have only been 2 studies so far looking at buoyancy and force exerted by bull kelp. So actually, I'm not sure, Dave, what you used, but so no is the answer I'm getting from the people who've done the work. So no, not yet, but that could be cool.
Yeah, thank you.
I will say, Markos, in general, I think we still have a pretty poor model on kelp drag. By their very nature, they've evolved to withstand the forces of waves and high currents in order just to survive. So what we see for drag on something that's tested in a tank or something like that, or dragging it around behind a boat, which is the only thing that we've done, it's not a good methodology for answering this. I think we are way overestimating the drag of kelp on these farm systems. I think we're ultra conservative on line strengths and connector strengths and anchor size. I think if anything we're going to learn over the next few years is we can economize and we can do better, and we probably won't have a big occurrence of failures, but we may have better economic successes by not doing this over-engineering.
Yeah, thank you. I agree with that, and certainly that's been our experience. Lexa, you grew alaria. Do you expect to see similar results with sugar kelp, or do you have an expectation?
Well, we'd have to test it to be sure. We can't just, but if I were to guess, back to the bull kelp and, sugar kelp growing together, those lines were spaced pretty close. Even with the sinking, they were still 30 inches next to each other, and the sugar kelp grew great. So maybe sugar kelp isn't as responsive to line spacing, but it's a fantastic project if anyone would like to check it out.
Yeah, Mike, do you have, you were growing sugar kelp in your trial. Do you think that line spacing was particularly important to the total yield? Or?
It wasn't in the experiment we did, because they had the same growth, the same weight for the different line spacing, whether it was basically 30 inches or 15 inches. But we didn't go farther than that. Yeah.
Yeah, we've tried a couple of things, and we've maintained 10 feet as our spacing, and it seems fine. But I think improving the density could very well make a difference.
Yeah, farms in the Kodiak Archipelago are down to 4-foot spacing for sugar kelp with still excellent yield. So, but what my array offered, the spreader bar system, and anybody can kind of replicate that, is that's something that you could put together and trial at your own farm site, regardless of species. So you could try bull kelp, you could try sugar kelp, even some of the newer species like maybe dragon kelp on that system. So it's very versatile, and that was another goal of our project, was to find a methodology that would allow us to test line spacing.
Great, thank you. Another question here, I think this one's for Angie. You said no farms have been successful at growing the desired morphology of bull kelp. What exactly is the desired morphology, and why?
Yeah, that's a good question. I probably should have clarified that in my talk. But so, as I mentioned, the formation of beakers really came from Barnacle Seafoods and the effort that they've been doing. And because they do a lot of products made from bull kelp stipes, such as kelp pickles, kelp salsa, they really do like to receive those really nice thick stipes that you can receive. So I guess the desired morphology is kind of the wild type bull kelp that you would see in a natural kelp forest. So the really tall, really thick, robust stipes with the additional blades. And on farms, we've just been seeing this small, skinny stuff, which could be useful. There's just not a market for it yet.
Yeah, thank you. Let's see. Angie, I think this is another question for you. It looks like one of the successes of the Beakers project related to ecosystem impacts. Are there findings that you can share?
That's a good question. So ecosystem impacts, it's definitely still a area that is being currently studied. Most of the successes that we've seen have been more observational rather than specific specific studies of the effects of ecosystem impacts. I know there are some projects being started that are beginning to look more discreetly at those ecosystem impacts, but most of the ecosystems impacts were kind of, let's see, what were they? I'm so sorry. I haven't looked at that list. Whoever asked that question, come find me later. I'll look at the list I have. It's a very long list of successes and challenges and notes on those, but I will check in on that for you, for sure.
Yeah, great. Thank you all. Thank you to our panelists. Thank you to everyone for your great questions. I'm sorry we didn't get a chance to get through all of them, but lots of opportunity here to speak with each of these people as you at the breaks, and thank you for the opportunity to come up and talk about bull kelp. So.